All right, guys, so moving on to our next lesson. Today we're going to be talking about central angles and arc measures. Okay, so dealing with a circle, we have from the center point to the circle. Remember, this is a radius. Then, of course, you have infinite number of radius inside of a circle. You know, basically all the way around. You can have as many as you want. Now, when you have two radius that meet together, they form what is called a central angle. So like right here, you have this radius AB and this radius BC, and right here, the angle in between them would be at 84 degrees. So now, this would be considered what is known as a central angle. So a central angle is an angle with its vertex at the center of the circle, and its two sides are radii. So radii is the plural word for multiple radius. The sum of all central angles in a circle is 360 degrees. So now what's important is that a circle all the way around is considered 360 degrees. So that means if you have a central angle here, central angle here, when you add all of them across, they have to add up to 360. That is just a fundamental rule of circles, that all circles must add up to 360 degrees. Okay? So an example of a central angle would be this angle right here, angle ABC. Okay, and then of course whatever the angle measure is equal to, that's the measure of the central angle. Okay, now what is created by the central angle is known as arcs. Okay, so like you have this arc right here from A all the way to C, arc all the way from A to C, this arc. It's like a portion of the circle, okay? The degree of the arc formed by the endpoints of a central angle is equal to the degree of the central angle, okay? So what that means is that if this central angle is 84 degrees, then the arc is equal to 84 degrees, okay? So that means if this is 84 degrees, then this arc is also 84 degrees. So right here, this is what arc looks like. It's the letters of the endpoints of the central angle, and then you have this little arc, little rooftop symbol above it, little curve, okay? So we read this as the measure of arc AC, which is right here, is 84 degrees. So now, if you remember in your notes, we introduced a while back ago, you were given two types of arcs. You have a minor arc and you have a major arc. A minor arc is an arc that has a measure less than 180 degrees, and it only has two letters in its name. So for example, right here, two letters AC, so this would be a minor arc. AC is a minor arc. Now the other type of arc that we have is known as a major arc. The major arc is an arc measure that is greater than 180 degrees, and it has three letters in its name. And of course, we need a third letter in the name to show that it's pretty much going on the larger side of the circle. So like right here, arc AC is 84 degrees. Then you have this arc all the way kind of around the circle. It goes all the way around, passing through D. Well, this would be considered arc ADC. So you see three letters, you know that it has to be bigger than 180 degrees. So now remember, we just mentioned that the circle has to add up to 360. So therefore, that major arc has to be 360 minus that 84, which is 267. So the measure of this major arc right here is 276. So the measure of arc ADC is 276 degrees. Okay, so you have minor arc, two letters, major arc, three letters. Okay, so this one has to be less than 180. This one has to be bigger than 180. And then, of course, going back to those notes real quick, there is a very special type of arc that we call a semicircle. Okay, so a semicircle is just where it's half the circle and it's equal to exactly 180 degrees. And of course, semicircles would also be labeled as 3 letters in arcs. All right, so let's do a couple of examples. All right, so if this angle right here, J and K, is 21, then this arc right here between J and K has to also be 21. Now also right here on the opposite side, these are vertical angles right here. So we are also dealing with, we have to remember our rules with vertical angles, with supplementary angles and complementary angles. So this angle right here is 21, then this angle right here is also 21, which means this arc right here is also 21. All right, now same thing right here. See how we form a straight line? 21 and this angle right here must add up to 180 degrees because they're supplementary. So 180 minus that 21, that gives us 159. So this measure right here is 159, which means this arc is also 159. And then same thing over here is another vertical angle. So this is 159, and this arc over here is also 159. And then from there, we have all of our parts of the circle labeled. So now we can go ahead and get our measures. So once arc JK is 21. The measure of angle JNM, so JNM is the 159. Arc KL, so K to L is 159. All right, so now this one's a 3-letter, so this one's going to be a big one. So we're going to go from J to K all the way to M. So from here all the way to M, which means I have to add up all of these arcs right here. So you're going to do 21 plus 159 plus 21. 21 plus 159 plus 21. And that gives us an arc of 201. Because I'm going from J through K all the way to M. So that pretty much that letter in the middle kind of tells you the direction that you're going, whether you're going clockwise or counterclockwise. All right, arc MKL. So go from M to K to L. So right here. So I didn't go this way because since that last letter was L, if I would have gone this way, it would have hit it already. So I have to go M to K to L. So all the way around. So there's 2 ways you can do this. One, you can add up all of these arcs right here, 159, 21 plus 159. Or since you're going all the way through the circle except to this part, you can just take 360 and subtract 21 because it does have to equal 360. So if either way, I can do 159 plus 21 plus 159, or I can do 360 minus that 21. You're going to see that it gives you the same answer. So that is 339. All right, let's do another one. All right, so let's get my measures. So this angle right here is 72, which means this angle right here is also 72, which means this angle right here is also 72, which means this arc is 72. All right, so this angle right here is 87, which means this arc is 87. And then right here, since this angle, all 3 of these angles have to add up to 180 because it forms a straight line, all I'm going to do is 180 minus that 87 and 72. That gives me 21. So this angle right here is 21, which means this arc is also 21. And then finally, to get the last angle, so remember all the sides of the circle have to add up to 360. So to get this last remaining one, I can take all of these and subtract them from 360. 360 minus 72 minus 21 minus 87 minus 72. And that gives me 108. So which means this arc right here is 108, which means this angle is also 108. And there you go. I got all the parts of the circle labeled, so now I can get my measures. So angle UXV, so UXV is 72. Arc ST is 21. Arc WV W to V is 108. TW, so T to W right here, so this is both of them. So I'd have to do 21 plus 72, which is 93. And then TVW, so T to V to W, so this way, TVW. So I'm going to have to add the 87, the 72, and the 108. So 87 plus 102 plus, 72 plus 108. There it is. 87 plus 72 plus 108, which gives me 267. And there you go. All right, so we'll go ahead and finish the rest of the examples in the next video. All right, guys, continuing on our lesson. All right, so first thing we're going to do is going to label all the central angles. So right here, because of this right angle box, that means that this angle right here is 90, which means this arc is 90, which means right here, because they form a straight line, this is also 90, which means this is also 90. Same thing right here, straight across, form a straight line, so this is 90, so this is 90 as well. And then finally, right here, this whole angle right here has to be 90 because this is also a right angle. So if this angle is 34, so this arc is 34, which means this angle is 34, which means that this angle right here, they're complementary. You're going to do 90 minus 34, which is 56. So this angle is 56, and this arc is 56. So once again, label all the parts of your circle, and then let's get the measures. So CD is 90. FD is from right here, so it's going to be the 34 and the 90, so 90 plus 34, that's 124. DCF, so all the way right here, DC all the way to F, so 90 plus 56, that's 236. And then GDF, G to D to F, so all the way around. So once again, you could do this two ways. You can add the 90 plus 90 plus 90 plus 34, or you can just subtract 56 from 360. It's going to be the same thing, which is 304. Excellent. All right, the next one. So right here, this angle right here is 19, which means this arc is 19. Right here directly across it is a vertical angle, so this is 19, this is 19. So now right here, this is a right angle, so that means that this has to add up to 90. So 90 minus that 19, that's 71, which means this arc is 71. And then because they form a straight line, this is also 90 degrees, which this is also 90. And then finally, to get this last part, this big one, all we're going to do is just going to subtract all of these from 360 because the full circle has to be 360. So 360 minus 19 minus 90 minus 71 minus 19, which is 161, which means this arc is 161. There you go. So label all the parts of your circle and then let's get our measures. So PQ is 71, SR is 161, QRT, so all the way right here, QRT, so it's going to be 19 plus 61 plus 19, 161 plus 19 plus 119, that's 199, PSR, so all P all the way to R, so 90 plus 19 plus 161, that's 270. And then PS is 90 plus 19, which is 109. Okay, so very simple. It is very important that you label all of the parts of your circle so that way you can get all of your arc measures. Remember that a full circle has to be 360. Remember your rules with like the 90 degrees and the 180s and your vertical angles. That'll make this so much easier. All right, so now let's get into a mix with some algebra into the mix. It's the same thing. All right, so we're looking for x. So we have this arc measure right here, which is 15x minus 26. And then we also have this arc measure right here that's 26. So now notice that from R all the way to T, this is a full semicircle or half a circle. So a semicircle has to add up to 180 degrees. Also the same thing if you want to look at the angles, this angle and this angle, see how they form a straight line, which is also 180 degrees. So basically this arc and this arc, they're supplementary, which means they add up to 180. So to solve for x, we're just going to set up 15x minus 26 minus plus 26 equals 180. All right, so the negative 26 and the 26 right here, these two kind of cancel each other out because one's negative, one's positive. So it becomes 15x equals 180 divided by 15. 180 divided by 15, that gives me 12. So x equals 12. So all we're doing is just setting up our equations based on what we know about the circle. You know, we knew that it was 180, so add them together and then solve for x. All right, so for number 6, so we have this arc right here that's 103, which means this angle right here is 103. This arc is 18x minus 2, and this arc is 15. So if you can kind of tell right here, from angle HIE, this full angle right here, and this angle right here, these are vertical angles, which means that these two arcs have to equal this arc. So basically this plus this equals 103, and then you set up your equation and solve. So 18x minus 2 plus that 15 equals this 103. Combine negative 2 plus 15, that's 13, so 18x plus 13 equals 103. Subtract 13, so 18x equals 90, divided by 18, x is 5. All right, so right here, for number 7, these are vertical angles right here, so vertical arcs. So that means that these two are equal to each other. So we're going to set this equal and solve. So 10x minus 22 equals 8x plus 12. Subtract 8x. That's 2x minus 22 equals 12. Add 22. 2x equals 34. Divided by 2, x is 17. All right, so now for this problem, we're going to have to plug the 17 back in to get the arc measures, and then from there we can get the rest of the circle. So if I plug in 17, it doesn't matter to which of those two you plug it in. So if I do 10 times 17 minus 22, that gives me 148. So that means that this arc right here is 148, which means this one's also 148. And then right here, they form a straight line. So if I do 180 minus 148, that gives me 32 and 32. So this arc's 32, this arc's 32, this arc is 148, and this arc is 148. So AD is 148. CD is 32. BDC, so all the way right here, BDC is 32 plus 148 plus 32. Gives me 212. And there you go. You got your measure. So it's a lot of once you find x, plugging it back in and then solve. Let's see, I think I can get these next two. All right, so same thing, solve for x. So notice that this is another semicircle. So these two are supplementary, so they add up to 180. So add those together, 17x minus 41 plus 5x plus 23 equals 180. 17 plus 5, that's 22. Negative 41 plus 23, that's negative 18, equals 180. Add 18, 22x equals 198 divided by 22. X equals 9. All right, so all we're going to do is just going to plug them back in. So this is 5 times 9 plus 23. That gives me 68. So this arc is 68, which means this one's 17 times 9 minus 41 is 112. Yep, and 112 and 68 out to 180. Which means this one's also 112, and this one's also 68. All right, so JK is 68. MJ is 112. LMK is all the way around, so 68 plus 112 plus 68, which is 248. I think I have enough time. Now I'm running out of time. I'll do this one more in the last video. All right, guys, so moving on to our next lesson. Today we're going to be talking about arc length. So now, please do not confuse arc length with arc measures. So arc measures, like in the last video we did, arc measures are equal to the degree measure of the central angle. What we're going to be doing today is actually finding how long the distance is between the points on the circle. So kind of think about it, if you were to take a part of the circle, you were to stretch it out in a straight line, and you want to see how far apart those points are. So basically what it is arc length is a portion of the circumference. If the circumference is the length all the way around the circle, an arc is a portion of that circumference. So we're going to be using the circumference to help us find it. So we're going to use the following formula. Okay, you are going to take x, which is the degree measure of the arc. So that means we're going to kind of go back to using this. We're going to have to get the arc measure. You're going to multiply it to the measure of the circumference. So either you're going to be given the circumference or you're going to have to calculate it. Either way, we have to get the circumference measure. So the circumference is equal to 2 pi r, or if you have the diameter, just d pi. All right, then you're going to divide it by 360. So by dividing it by 360, that gives you the portion of the circle, because since a full circle is 360, so to get a fraction of it, you have to divide it by 360. So we're going to use this formula right here. All right, so look at number 10. It says, if EB is 15, find the length of arc CD. So they give us EB. EB is a radius. So they give us this on purpose because we need to calculate C first before we can do the formula. So this goes back to what we were doing with circumference. Circumference is equal to 2 pi r. Well, if EB is 15, that means that r is 15. So then C is equal to 2 pi times 15. So then what we're going to do is we're going to multiply 2 pi times 15. That gives us 2 times 15, which is 30. So 30 pi. Okay, so now we're going to take this 30 pi and we're going to find the circumference. I'm sorry, the arc length. All right, so we're looking for CD. So CD is this length right here. So the first thing I need to do is I need to get the arc measure. So this length right here is 68. Then right next to it, remember this is also 68. This one, since it makes a half circle, I'm going to take 180 and I'm going to subtract that 68. And that gives me 112. So this length right here is 112, which means the arc is also 112. So now I'm going to use this 112. This is my x, so x equals 112. And I'm going to plug that into the formula. So it's x times c divided by 360. So it's going to be 112 times 30 pi over 360. Okay? So we're just going to multiply the top first. So we're going to keep this in decimals. So we'll just go ahead and just keep it round it to the nearest hundredth. So we're going to do 1/12 times 30 pi. Press enter. And then whatever we get, just divide it by 360. All right, so that gives me 29.321. Since I'm rounding to the nearest hundredths, I'm looking at the third number. This will keep it as a 2, so it's going to be 29.2. So I guess if we call it, let's call it L. If L will equal 29.32. Real simple, just using the formula. All right, number 11 says if NR is 8, find the length of arc NMP. So NR is a radius, so I need to get the circumference first. So circumference is going to be 2 pi times the radius, which is 8. So circumference 2 times 8 is 16 pi. All right, now x is the arc measure. NMP, so NMP is all the way around right here. So this part right here is 162, so if it's a full line from NQ, 162 from 180. That gives me 18. So this arc right here is 18, which means this arc right here is also 18. So it wants NMP, so from NM all the way to P, so I have to do 18 plus 162 plus 18. So add them all together, that gives me 198. So X is 198. So now I have my X and I have my C, so now I can use my formula. So it's going to be L equals 198 times 16 pi divided by 360. So 198 times 16 pi, and then I'm going to divide that by 360. And there it is, 27.646. So this 6 is going to round it up to 65. So L equals 27.65. Very simple. I mean, just you're gonna have to do a little bit of what we did. We know how to get circumference. We know how to get arc measure. So once you have them both, just put them into the formula, and then you're good. All right, number 12 says if VS is 12, find the length of arc UT. So now VS is kind of nice because VS is a full diameter, okay? So if your full diameter is 12, then I can use this d pi formula. So that means the circumference is equal to d pi. If diameter is 12, then circumference is 12 pi. All right, next let's get the arc measure of UT. So UT is right here. All right, so we're going to use this right angle to help us get it. So notice that it's a vertical angle right here, VR, from U to S. So since this is 90, all I'm going to do is take 127 and subtract 90, which gives me 37. So this is 37, which means the arc is 37. So that means X is 37. All right, so using the formula, L equals 37 times my circumference, which is 12 pi, divided by 360. So 37 times 12 pi, divide that by 360, and there it is, 3.874, which rounds up to 3.87. All right, number 13, JH is 21, so once again it gives me a full diameter, so that means the circumference is just 21 pi. It wants to find the length of KJG. So from K through J all the way to G. Okay. So to get this one, right here, this forms a straight line. So I have to subtract 180 and 85, which gives me 95. So this one's also 95. So to get KGJ, it's all the way around. I'm going to add up 95, 85, 95, and 59. So 95 plus 95 plus 85 plus 59. That gives me 334. So x is equal to 334. So using the formula, 334 times 21 pi, all divided by 360. 334 times 21 pi, divide that by 360, and that gives you 61.20, that rounds it up to 1, so 21, 61.21. That's all. Very simple, just using the formula. All right, let's get the last two. All right, FG. So FG is a radius. So that means I need to multiply it by 2. So it's 2 pi times 27. So 27 times 2 is 54. So 54 pi. All right, it wants the length of arc FED. So F